because it's something that shows up later on in math, like in algebra 2 and in pre-calculus. Actually, in pre-calculus, you'll talk about what a dilation does. Dilation, like if you think about when your eyes dilate, right? What does that mean?
Get bigger.
Okay.
That happened to me.
Or smaller. So the transformations that we've looked at so far have all been congruent. We had a word for that. It's the only... Well, they're similar, that's true, but it starts with an I. Isometry.
Nice.
So here, congruent, this is an isometry. That's it. Really the only important term that we have in this chapter, just besides the translation, reflection, rotation, those transformations. Isometry just means when the figure stays congruent. Dilation, they don't necessarily stay congruent, but they do stay similar, which is why they have a scale factor. So we did scale factor back in chapter 7. Like if we say a triangle has a scale factor of 1 to 2, another triangle. Right, so all the ratio of the sides would be 1 to 2. So if I knew one side was 8, then the other side has to be 16, the corresponding side. Okay. In dilations, we're going to use the letter R for the scale factor. It's just the letter that they use in this part of the lesson. Okay, so yeah, these can be difficult. You'll see with finding the actual measurements, it's easy. It's the drawing of them, just like with reflections and the rotations. We found that when you have to draw them kind of freehand, it gets to be really complicated because you get all these dotted lines. So we still have to have this center. Notice here's the center. You have to have a center point of the dilation. Take a look at triangle ABB. Here's the blue triangle ABB. If we were to connect, you see how you have these dotted lines connecting your center, kind of like what we did when we had the rotation? If you were to measure, so let's measure from A to C, for example. Measure from A to C. A to C. Not A prime, just A to C. Okay. So if this is 1 inch, then that means from A to A prime is going to be 2 inches because I wanted a dilation of a scale factor of 2.
What you mean from A prime to C?
No, okay. Measure from A to C. You said that was about 1 inch? Yeah. So that means from C to A prime.
You said A to A prime.
Oh, I'm sorry, because this is another inch. You're right. So from the scale factor, right, is 1 to 2. So this distance should be a ratio of 1 to 2. You could check the other one. So from B to C, if you were to measure that, what do we get? From B to C, it looks like 1 1.25. Yeah. So then from C to B prime should be 2.5. Okay. Now notice this triangle ABD is smaller. So whenever your scale factor is larger than 1, your resulting triangle after the transformation should be bigger. And it's getting kind of like you just extend triangle ABD compared to triangle A prime, B prime, D prime is twice, right? The ratio is 1 to 2. So whenever this dilation is bigger than 1, your result is going to be bigger than your original. So take a look at the next one. This one has a scale factor of 1/3. So what's happening this time? It's going to get smaller. So notice here, this is my original. And then what happens? Well, your resulting gets smaller. So how would we figure that out? Well, if you were to measure, so here's our center is x. So let's just say you measure from n to x. Go ahead and do that. Measure from n to x. N to x. What do we get for that? About 1.5 inches.
No, 1 and 3/4.
No,
I mean 1 and.
what are we measuring from?
N to x.
It's pretty much 1.5. About.
No, it's less than 1.5.
It's a little bit.
Is it easier to do in centimeters?
Yeah, probably. Let's do it that way.
Try centimeters.
It's about 3.5 centimeters.
No, it's 3 centimeters.
That's 3 and
It's 3.5. It's like 1 1/3.
Whatever unit you use.
3.5 centimeters.
Okay, so we'll say 3.5 centimeters.
Yeah.
So, how do I find n prime to x? Well, I would, if this is 1/3, I would take 1/3 times 3.5, or 3.5 divided by 3. It's an approximation. So this is going to be what? About 1/3. A little bit bigger than 1 centimeter would be the distance. No, because it's a third of 3 is 1. What's a third of 5? Okay, fractions.
1 and 2/3.
Do you want me to change?
5/3.
So-
3/4. 5/3.
If I have 3.5, that's really what? 7/3. What's 1/3 of that? 7/6. So it's 1 and 1/6. If you measure, is this about 1 and 1/6 centimeters? What's 3.5? Okay. Was that confusing?
I think it's
Okay. Let's just look at this. This is something that I've already mentioned here about what happens when your scale factor, okay, R, so when that's greater than 1, it's getting bigger. It's an enlargement. When the dilation is between 0 and 1, that's a reduction. And if it's equal to 1, then it's congruent. So we don't deal with below 0. Here's the reason. Did you see the lines around R? What's that mean? Absolute value. So sometimes we have a dilation that's a negative number. What happens is the figure gets translated the opposite direction, but by a scale factor of 2. So can you kind of picture the last, what we had up here? So let's take this one. Let's say here's triangle ABD. If this was R equals -2, what would happen with our figure? It would go the opposite direction. So, no, it would still get bigger. So if this was R equals -2, basically what happens, if you were to connect, if you were to draw these, just see the dotted line, and then just keep drawing 2 inches this way. Well, that's what we're going to look at the example. So it's kind of hard to see at this point, but
It has measured on the back.
yeah, I think I gave you an example here. Okay, so we have here, if you know the length of the segment, so for example, here's ED. Here's ED. Let's give that a measurement. Just measure ED. What's that? You want to?
I didn't measure it.
You want to measure it real fast? What's ED?
Can we just make up numbers?
It's a little bit more than half an inch. It's 1.5
Okay, so
centimeters.
Not even a half.
1.5 centimeters.
I got like 1 centimeter.
It's like a half. Can we just put 5?
Just put 5.
Oh, it's half an inch.
Just put 5.
That's 5.
No, 5 isn't a real thing. Let's just put 5 because it's easy.
Yeah, it's exactly.
Okay, so if it's a half an inch, so if R equals, let's say R is equal to 2, what's the length of EB? Well, we just multiply it. 2 times a half
Oh, it's 1.
is 1. Okay.
5.
Well, if you're measuring in different units, it's fine.
I don't even know what AD is.
Well, no, just look at the next page. Okay, this is what I'm talking about. This is probably the easiest thing with blue all tapping. This, right here.
This, right here.
I want to know the measure of the dilation image A prime B prime of the Fourier image AB. Okay? So actually one we're working forward, one we're working backwards. So I want to know A prime, B prime. So remember, what was the rule? It was the scale factor, absolute value of the scale factor, times, okay, what's the absolute value of 2? 2. So 2 times 12 is 24.
That it?
That's it.
I don't understand it. I don't. Can we just go back to the video before for a second?
Okay, basically what you do, I can write it out in words if that makes it easier. Image, so the image is, guys, is the scale factor times the pre-image. Guys, the pre-image is the 1, the pre-image is this, the image is the one with the prime. The image is what you get after your pre-image. Think of pre-image, that's what you start with, and then the image is the result. Okay?
I'll just remember the numbers.
Image is, or you can think of this, you can think of the one with the prime. The one with the prime is equal to the scale factor times the original. So this time I'm missing a B.
Wait, so is it 36 equals?
So it's absolute value of R times AB. So this time we have 36. We have R is 1/4. So we want to come up with,
Multiply the other side by
alright, just multiply both sides by 4.
Wait, what?
I like how you guys raise your hand, thank you.
Sorry, I'll raise my hand.
You guys have such good manners.
Just in case my hand is weird.
I can't do that.
No, I was reading it.
144. You didn't hear me, so you can still do it.
I got 124. I did it right now.
Okay. Listen, you're either multiplying or dividing sometimes, depending on what situation you're in. Yeah.
You jabberoo.
Oh, so sometimes, remember how I showed you on the previous page, sometimes you go the opposite direction when you're doing it? So you'll see in the next example. But when you're talking about measurement, you always want to make it positive. We can, so we need the absolute value sign. You draw it. If it's involved, then as long as you just make it always positive. Okay. So here's a dilation that we want to create. Center C and R is -1/2. Okay, so let me just explain. The triangle that we get is going to be on the opposite side of C, and it's going to be half as big. All right, so what I want you to do, let's just start with K. Start with K.
Okay.
Draw a dotted line from K to C. Now, at the same time, if you could measure from K to C, that helps. What's the measurement from K to C?
An inch and one
A
little more.
little more. Can we say
Okay.
it's like, it's barely over an inch.
Okay, so what you want to do is you want to continue that dotted line for half that length. So if you said this was a little over an inch, then you'll go a little bit over half an inch more. Does that make sense? So just continue the dotted line about, well, you guys said on yours, if this was an inch, since this dilation is 1/2, we want to make this about half the length of this one. And this point is going to be K prime.
Whoa. Okay. Oh, okay, I got it. I get this. Okay.
Now we do the same thing with the other one?
Yeah, go ahead and do the same thing with the, so we're going to do the same thing with J, same thing with L. but it gets
You're going
flipped
past it because it's negative. Right?
because it's negative. So we continue past the point because it's negative. It's on the opposite. It literally just goes across C.
Well,
If it was just a half,
If
then
it-
we would put it like right in the middle. Okay, so I'm going to continue with J.
Is it sand or needles? It's not sand, it's needles. Ah.
Why not even mean?
Alex Feldman.
When you're supposed to sleep, it sometimes feels like sand and it sometimes feels like needle.
Mostly for me.
Needle.
Why would I mean needle?
It's like where it's like stuck.
Oh wait, I don't think I measured that right. Mine looks like that's no, I need to do 15.
Just like
Oh, I didn't.
No, that's the sand.
No, it's like two.
Yeah,
That's the sand.
That's only one.
I think I didn't
You
measure
have
mine
the needles.
very well on here.
And you guys
I
said
get
the
it.
needle.
You guys have more accuracy on this.
This case, if you get more sand or needles.
So keep going, and then just connect your 3 points after that. Yeah, that was good.
I never get needles.
Sorry, mine got off on mine.
Mine does not look very
I
good.
don't know.
And wait, so Miss Casey, what would you do if it was if it wasn't negative?
Wait, so
Wait, I think that's right.
wait, Miss Casey.
Yeah.
On this one, you measure the length between like J and the
Yeah,
E,
so go
and
from
then
J to C,
C, and then you
and
extend
then
it
extend it half of that length.
I can't do James.
Okay, so you measure the distance between J and C, and then cut it in half. And then,
Okay, is it supposed to be a triangle? Because mine is.
It's supposed to be a triangle.
Well, oh wait, it is a triangle.
It's supposed to be similar to figure.
Okay, so mine's
It's just a lot smaller.
It's supposed to be smaller, guys.
But mine still looks really wrong.
Guys, it's supposed to be, each of these sides should be half as long as the original. It should be a lot smaller.
Oh my god. Okay,
I think the back's faster than that.
mine's this now. Can I do this right?
Hold on a second.
Your back spends
you have problems. I look pretty long, but
What?